recently here. So let's put one last problem for this chapter together here, and we're going to go with this one. F of x equals 6x to the third minus 4x to the second plus 3x minus 2. Alright, so we're going to do a couple things with this. We're going to start out finding our p's and q's like we did earlier. So remember, the p is going to come from the factors here. So p's plus or minus 1 plus or minus 2. Our q's are going to come from our lead coefficient. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So again, now when we combine those, these are all possible rational roots. So we do p over q. So I'm going to get 1 over each of these, plus or minus 1 over each of those. So plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. Now I'm also going to use the 2 here over each of these. So I'm going to get plus or minus 2. Now 2 over 2 is 1, which we already have, so I don't have to repeat that. 2 over 3. And then 2 over 6 reduces to 1/3, which again I already have. So right now I've got 2, 4, 6, 8, 10, 12. So there's 12 possible rational roots. Now again, when we did it earlier in the chapter, we could have tried every one of those, but if there was a way to do this and shorten it up, obviously we want to do it because these problems get to be quite long. So let's look at a couple situations here for description purposes. Let's go to Descartes' rule. So remember, we're starting with this. Here's all of our possible. Now remember, Descartes' rule says, take our original function, 6x to the third minus 4x squared, 3x minus 2, and again we're going to count our sign changes. So positive to negative, there's 1, negative to positive, there's 2, positive to negative, there's 3. So that means we're going to have 3, but remember we're always subtracting even integers, so 3 minus 2 is 1. So as far as positive possibilities, we're either going to get 3 positive or 1 positive. And up here we had 6 positive rational possibilities. Obviously they're not all going to work. So we do f of negative x. And I'll shorten this up and kind of walk through it. If I put negative in here and cube it, I'm going to get negative. So I'm going to get negative 6x to the third. If I square a negative, I get a positive times this negative stays negative. Here, positive times negative is going to turn into negative. And there's a negative. So on this one, negative to negative obviously doesn't change. Negative to negative doesn't change. Negative to negative doesn't change. So this one tells me there shouldn't be any negatives at work. So when I look at my total possibilities for this situation, positive, negative, and imaginary, remember my total for this problem, it was a third degree, so my total is always going to be 3. So this one, my combinations, 3 and 0 or 1 and 0, and I end up with that. So I'm either going to get all three of them to be positive zeros, or I'm going to get one positive and two imaginary. So I shouldn't end up with any negative when I go through this. Alright, so that's that part. Now let's take a look at our upper and lower bound. Alright, so let's start with our lower bound. Now I kind of got an idea what it should end up with here, but let's just walk our way through it real quick anyway. So our lower bound first. So if we do this, I've got a 6, -4, 3, and -2. Now he said lower bound go negatives. So I'm going to go -1 is my first one. Now again, if you remember, lower bound, what our rule was we were trying to get it to alternate on the bottom. So it's positive, so I'm going to hope that this is going to turn negative. So -1 times 6 is -6. There's -10. So we're still okay, positive, negative. -1 times -10 is 10. Add that up and I get 13. Positive, negative, positive. -1 times 13 is -13. Add it up and that's -15. So that's going to tell me one thing about my problem here is when I look at all my options, -1 is going to lower bound. Now, because I didn't get a 0, that also tells me -1's not going to be a root. So I could say, hey, open circle, it's not going to exist. But it also tells me everything to the left of -1 is also not going to work. So -2, that's out. And I guess that's the only one that goes out other than -1 didn't give us a 0. So that's out. So all of a sudden now we're down to 10 possibilities. Not a big change, but it helps a little bit. Alright, for upper bound. Again, to get all positives on the bottom. And again, just to save a little time, I cheated and went through, but we're going to start with positives here. So we're going to put a 1. So 1 times 6 is 6. Add them up, I get 2. 1 times 2 is 2. Add them up, I get 5. 1 times 5 is 5. Add them up, I get 3. Now again, this told us a couple things. We did get all positives, so that means this is an upper bound right there. And also with the 3, it wasn't a 0, so factor theorem falls out, or remainder theorem falls out as well. So 1's not going to be a 0. But that means that's my upper bound. So that tells me every answer I get should fall between -1 and 1. So if I went up here again, we said 1 didn't work, so that's out. So that whole option's gone. Everything bigger than 1. Well, again, the only other thing here bigger than 1 was 2. So that was out. So we got rid of 2 more. So we went from 8 possible choices, or 12 possible choices, to 10 and finished with 8. So that means every possible 0, once we go through and solve this thing up here, is going to be between -1 and 1 if it exists. So we'll let you do the work to find out what those actual zeros are on your own. So have fun with that one.